Okay, so for today, we're looking at modeling functions and applications. Our main goal today is to sort of come up with a model and identify the appropriate models for given situations. We've got a few little goals today. We're going to work at understanding a little bit of regression models. We're going to have a go at solving problems using direct and inverse variation. And we are going to have we're going to try and have a few minutes at the end to get you familiar with piecewise functions, although we will look at that in a little bit more detail later. So, our first one is a bit of review. You should have seen this type of thing before in the last courses. We're going to be building regression models. So we've got the table of data here. If we look at that table of data, we have to determine what type of model it is. In this question, we're asked to find a linear model, but we will also sometimes just be asked to find a model. So we're finding a linear model. This is the basic routine. What we want to do is take out your graphing calculators now in your hand. I want you to follow along with your graphing calculators. Take out your graphing calculators. Following me along. Let's have a look. We got this data here. Let me throw this over there. Pull up my calculator here. What we need to do to begin with on the calculator is we're going to add a new page. So we press Control, Add. Let me start right from the beginning to go back one step. We go back one step. Start by pressing On. You come here. Choose 1. Press 1. New. Say no, I don't want to save. Add a calculator. Always start with a calculator. Then at this point, press the Control button there on the left and Add Page, which is here above Documents. You can see where I'm pointing. And we are going to choose to add a list or spreadsheet. For this first set of data, we're going to give it some label names. And we're going to label this column as X, and we're going to label this column as Y. Be careful not to write anything in this row. This is for adding in formulas. We don't tend to use this one much. Then we add in the data. We've got 4, 5, 6, 8, and 12. So type the data in that you see. Make sure you type it in correctly. The main area for mistake in this is that you don't type them in right. Some people get stuck when it comes to calculating because they do this. They stop there. Notice how I've not entered that last one in. A lot of people put their hand up and say, oh, my calculator doesn't work. And this is because they haven't entered that last one. Make sure you enter that. It's a common error. So we are asked to find our regression model. So you can press the Control button and then scroll to the left. Brings you back onto this page, or you can click it there on the top using the touchpad. Are we all there at that point? Are we all good? Yeah? Okay. So then we're going to press menu 613. So menu 613, linear regression model. Press to the right, select that, press to the right, select that one. Just before we press OK on this, notice which equation this is going to be saved in. So our equation is going to be saved in F1. It uses the first empty available slot. If you have functions in there already, it might come in higher. But if you started with a new document, you should be on F1 as well. Let's click OK. Here we see our regression model. Now, depending on how many significant figures you want to be giving, I've got mine set to 3 significant figures, which is usual. You can change this by pressing the document button there. See the on the top right, the document button? Document 7.2 will bring you to this, and you can choose between float, which gives you all the decimal places, or you can choose, I like to have it on float 3. Float 3 means 3 significant figures. And if you scroll down, you've got fix, and that's how many decimal places, fixed number of decimal places. So fix 3 is 3 decimal places. Float 3 is 3 significant figures. And then press enter again and write it something legible. I'm going to type this in here today. So for A, we have the answer. A linear regression model is used. Write an equation for the model. We need y equals 0.185x plus 3.55. Using the linear model from part A, what is the predicted weight in kilograms of a baby that is 10 weeks old? So in this case, we can use the calculator. What we want to do on this one, let me write up algebraically, we are finding y of 10. So we can type that in. It would be 0.185 bracket 10 close bracket plus 3.55. Now those values are rounded to 3 significant figures, and you should always work with exact values. So instead of typing in like that on the calculator, I'm going to press this variable button. Notice here above the 9, we've got variables. This pulls up F1. I can choose F1 here at this point, and then I can type in 10 and press enter, and I will get this. Notice there's only 2 significant figures. I want to know, has that been rounded or is that an exact value? So I'll just change my document settings back to float. Press enter again. I see it's rounding it. So to 3 significant figures, this is going to be 5.40. Oh, wrong place. 5.40. And that's the value to 3 significant figures. You notice how 5.40 gets rounded on the calculator to 5.4. Even though the calculator is operating in 3 significant figures, it will always not show the zeros, which is not correct for 3 significant figures.
I missed that.
So
how are you able to get the function?
just recapping the whole process fairly quickly, I went over to here and I entered in the data. I've got the X and Y values here for the data. Then I go on to the calculator page and I press the menu button and I choose menu 613. Oops. Menu 613. Pulls up this dialog box. I can enter in, I want to use X and Y data sets, and this time it's going to store it in F2. Notice it's storing it in F2 this time. I press OK, and this gives me the linear model. So if I look here in this big mass of what it's saying, it says that the regression equation is of the form m times x plus b, where m is given as 0.185 and b is given as 3.545. Also, this one here is useful, this Pearson's product moment correlation coefficient, or the correlation coefficient, R, which will measure the strength of the correlation here. So a value close to 1 is very strong. Anything over 0.9 is very strong. A negative value means we have negative correlation, means graphs going down. Any value where the absolute value of it is less than 0.5 or 0.4 even is quite weak correlation. It means the model might be unsafe to use because we will look at it in more detail. The data is scattered quite widely around the values. So it measures the strength of the trend and gives you a statistical measure of that. Now, this last one is a problem. Do we have any AP Stats students? Yes. Now, you're going to have to close your eyes here. It's going to curdle your blood. Because what we've calculated here is the regression of y on x for this data set. This question, and I've seen one on the AP exam, it asks you to calculate a x value given a y value. Now, any AP Stats student should know we shouldn't be using the regression model of y on x for that. We should be using the regression model of x on y and then entering the value and calculating. And you'll get a different value. I did it, it's 47. Was it this question or the later one? It's the one on the exam. So we're going to do something here. I'm going to show you how to do it. It'll make complete sense to you and there won't seem any problem whatsoever. But trust me, once you understand your statistics better, what I'm about to show you is something I don't wish to do. Bad math. Okay. So what the question, if we read the question, it says the weight of a baby is 5.3. The weight of a baby is 5.3. And we need to know what the age is. So that means we are putting in the equation 5.3 is equal to 0.185x plus 3.55. Now, there's nothing wrong with this equation. Perfectly normal. A lot of you are recognizing it. But what it is we are using y hat here. Let me see if I can find a little hat symbol. Add it. So this is a y hat. Let me see if I can pop that in the right place. Will it let me stick it there? Yeah. There's my hat. So if we've got the regression of y on x, which is what the y hat is telling us we shouldn't quite be doing this, but we're going to do it anyway. Let me show you how to do it on the calculator. So for this one, we want to solve that equation. We want to use the exact values, so I'm going to press Menu, Algebra, and I'm going to end solve this one. So there's end solve. Then I want the equation 5.3 is equal to, I'm not going to type that equation in, I'll just press, I typed it in here, F1. So F1 of the variable x. And then to make end solve work, we press comma x. We need to understand that this is a linear function, which is only going to have one solution. And therefore, we don't have to worry about how we use end solve to look for the second solution. So this will be enough for us. There's our answer. I'm going to round that to 3 significant figures. Document 7.2. Oops, missed. Sorry, document 7.2. Put that into 3 significant figures. Press enter again. There's our answer. So this implies that x is equal to 9.49. All right. Yes.
So is there any way to do the step number B without the calculator? Or do you need to?
Yeah, well, you can just like that. So it's going to be 18.5 plus 3.55.
To find the equation for that.
No. There is a process for finding step A, you mean, without the calculator. You can find step A, obviously, without the calculator, but it's a long process. So we're not going to do that without a calculator. Absolutely not. Yeah, that's why I'm recording. You use yours. You need to know how to do this. You should do it on your calculator, whichever calculator you're going to train on. So to help with the calculators, obviously everything on this course at this school is going to be TI Inspire. I have managed to post documents for CG50 and TI-84s for this one. I don't have a document for the Desmos approach. Any of those are acceptable. Whatever calculator you use on this course is the one you should take your exam with. You shouldn't switch at the last second. That would be foolish. But yeah, make sure you train how to use it. And I'm posting the video of today's lesson. Any questions? Let's move on. Wait. Bassa, would you mind lowering the AC a degree? It's hot and humid today, isn't it? I don't know. Zahan doesn't feel it. He's got his jumper on. Shana. Okay, let's have a little read through what we've got here. Yeah, look. You don't have anything inside your bracket. Absolutely nothing. Okay, so what we're looking at now is how to select a model. This is the main focus for today's lesson, is how do we select whether it's quadratic, it's linear, or it's cubic. At this point on the course, it's going to be polynomial or rational. We haven't covered the later options that we'll see in the next unit. So at this course point, it's pretty straightforward. One of the best ways is looking at the rates of change. So if you have a constant rate of change, now you're not going to have the same value with the regression type approach. When you're looking at a table of data like that we had here, you're not getting, even though this is linear and it's a really good fit, it isn't a constant rate of change. It goes up by 0.2, by 0.4, by 0.3, and that last, the x values aren't the same. So it goes up by 0.2, 0.4, 0.15, and then this one 0.1 something or other. But it's approximately, it's roughly a constant rate of change. It's always going up. It's always going up by 0.1 something or other. 0.1, 0.2. There's not a huge variation there in how it's changing. That is what we recognize as linear. So linear models is where you have a roughly constant rate of change, or from the context, you're like, every time I have another one of these, I'm going to get another one of those. And that sort of linear relationship between the values. Like the more tomatoes you buy per kilo, the more the price goes up. Those sort of linear relationships that you see in everyday life, you should understand to be linear models. Quadratic models. Now, in this case, what you're going to see is the rate of change is not going to be constant, but the rate of change will follow a linear pattern itself, or the second rate of change will be roughly constant. Otherwise, you're going to see some sort of symmetrical pattern with symmetrical growth. Now, it's going to increase and then it's going to decrease, or it's going to decrease and then it's going to increase, but it's going to do that in a symmetrical way. Because if you imagine a cubic function, it can increase and then decrease if we don't go over the whole function, but it will increase slowly and then decrease fast in the middle. And it won't have that symmetry to it. Another thing to spot, area. If we're calculating area, that's typically going to be a quadratic model. Same for cubic models, and they're going to be involving volume. All right, so we have a question here. For this situation, is it cubic, linear, or quadratic? Balloons are filled with water in preparation for an epic water battle. Each water balloon is roughly spherical. The radius of each water balloon is measured relative to the amount of water it holds. Discuss with the people next to you. What do we think it's going to be and why? Further. Okay, what do we think it's going to be? What do we think it's going to be? Cubic, why? The radius is linear, and the relationship of the radius to the amount of water would be a volume formula, which is cubed. Yeah. Do we know the formula for a sphere? 4 pi r cubed over 3? 4 pi r cubed over 3? Okay. Right, let's have a look at this next one. So we got a table of ordered pairs here for this one, and we need to determine firstly what type of model it's going to be. So get your graphing calculators and your little mitts again. We're going to enter the data. So when I enter the data this time, I'm just going to scroll across over here, and I'm going to put in two new labels. I'm going to call this ones A and B. Then I'm going to type in my data for these ones. So 0, 0.4, 0.9, 1.2, 1.7, 2.2, 2.9, 3.4, 5, 10.6, 15.4, 17.1, 18.0, 16.5, 10.2, and 2.8. Just double check your data, make sure it looks right. We just check it through. Yeah, looks good to me. Nope. Okay, so what I see from this data is, look, we're at 5, 10, 15, 17, 18, 16, 10, 2, 3. We are going up and then we're going down. Notice how we're going up by 5, 2, 1. We go down by 1.5. We go down by a little bit more, 4. We go down by 7. Roughly symmetrical. So this is going to be quadratic because it is roughly symmetrical. But what we want to do is we want some help with that. So I'm just going to write firstly, what does it say? It says which type of, so I'm going to say this is quadratic, as the data increases to a maximum and then decreases in a roughly symmetrical way. Also, we can add in a sketch of the scatter plot. So let me show you how to do that. We're going to press Control, Add Page, and we're going to choose a Data and Statistics page. Number 5. Add yourself a Data and Statistics page. Scroll down to the bottom here with your touchpad and click, and then choose A. Scroll over to the left here and click and choose B. What does that look like? Yeah, that's quadratic. So you can add a little sketch of a scatter plot, label the axes a little bit. Doesn't have to be drawn accurately. Draw a rough sketch, label the size, the maximum value, and the minimum values. That should be enough, and have it roughly right. So write an equation for this. I can grab the equation here on this page. Let me show you how to do it here. I can press Menu, Actions, Analyze, Regression, and then Quadratic Regression. There we go. So we have y equals minus 4.88 x. I can only do the square. Oh, no, wait. Squared plus 16.0 x plus 5. There's a regression model of a quadratic. Okay, let me just stop the video there at that point.